Okay, look here. Question 10 is given. You are told that a curve is given with the gradient function dy dx equal to kx plus 3. Am I right? There is a point P. The curve actually passes through the point P. The gradient of the normal is negative 1 over 15. Some of you went to integrate immediately. Okay, I wouldn't do that. Why? I wouldn't want to integrate immediately first. Why? Okay, first thing, there are two unknown. There's a K, and then the thing there's a C when you integrate. More importantly, can you read the question? Part 2 asks you to find the equation of the curve. Only part 2 you need to integrate. Am I right? So part 1 you must be smart enough. You need to integrate first. So I cannot use this immediately in part 1. So if I don't use this, I must use the other information. Am I right? How are they related? The gradient of the tangent times the gradient of the normal will give us negative 1. So let me do that. Gradient of tangent. Of course, you don't have to write this up. I'm just writing to tell me what I'm doing. Because of the relationship, they must be perpendicular to each other. Am I right? So let me write down. Kx plus 3 multiplied by negative 1 over 15 is equal to negative 1. But I'm still stuck. How to find k? There's an x over here. Please remember, when does this relationship happen? At point P. So I'm supposed to substitute point P inside here. Am I right? Of course, my method is very long. Some of you will just tell me, Mr. Liu, kx plus 3 is equal to 15. Straight away sub inside faster. Okay? Because it's a negative reciprocal of negative 1 over 15. Substitute inside, so this is 3k plus 3 is equal to 15. I think all of you found k to be equal to 4. Am I right? Now we are ready. Why? Because in part 2 they say find the equation of the curve. Why we can do that? Because we found the value of k. We found the value of k. Now integrate with respect to x. This is very easy. I'm not going to ask anyone. And what do you notice once again, this is a work problem. You notice the integration is very easy. It's the same like differentiation. Whenever it comes to work problem, we cannot make the expression too difficult for you all. Is this good enough? Why not? We need to find the value of c. How to find the value of c? Use the point back again. Okay. Do you notice that every time I write this down, but do you get penalized if you don't write this? You won't. But I want to write this because sometimes there are too many points already. You must make sure the point you're using must be a point that lies on the curve, or the curve actually cuts through the point itself. Something like this. Correct? So 19 minus 18 minus 9, so you get okay, now comes it's not a thinking question, it's an application question. Find the stationary coordinates of the turning point. What do you mean by turning point? Can you remember? Stationary point. So what will happen at stationary point? Gradient is equal to 0. Remember? All these turning points. The gradient will always be equal to 0 at turning points. Am I right? So what do we equate? dy dx equal to 0. So in this case, your dy dx is 4x plus 3. X must be equal to negative 3 over 4. How to find the value of y? Sub it into this equation, not the dy dx. Sub into the equation of y. What do you all get? So okay, now I'm going to ask, do we need to prove whether it's a maximum point or point inflection? No need. When do we need to prove? Ask you to determine the nature of the turning point, then you need to do that. Okay?